Greetings and welcome to the video on the confidence interval. Let me go ahead and get this on the canvas for us. Confidence interval. And I've kept a little bit of the drawing from the previous video that was on sampling distribution, just to kind of remind us of kind of where we're at with the example. But let's just kind of suppose now how we could use x bar from our sample to estimate what mu would be in the population. Because we know, I'll just draw this down here, that the point estimate x bar from our video on point and interval estimates, the estimate x bar equals mu. Now, will it equal mu exactly? No, it will not always equal mu exactly, because there will be some sampling error in there, that not every individual that you have in your sample will well represent what mu is in the population. So whatever your sample mean is, it will be slightly different. But how much different? Well, we can create an interval or a range or a band around what mu could possibly be based upon our x bar, and we kind of do that by using this standard error of the mean concept. If you think back to let me use blue here. If you think back to the normal curve, which I have up here on the right, you know, if I wanted 68%, would be approximately from these inflection points on the normal curve, and this would capture 68% from here to here. Okay, and what does that correspond to in terms of a z-value? Well, it corresponds to a z-score of an absolute value of a z-score of 1, right? So these values right here. So plus or minus 1, a z-score of 1 will give you 68% of the scores. So if I wanted, again, this is building off our concept from before, but if I wanted a 68%, which I can denote as a proportion here, a 0.68 confidence interval, that is essentially saying I want a 68% confidence interval, that would equal my sample mean, my point estimate, and then I need to create an interval by going plus or minus, and I can do 1.0. Actually, what I should do is back up here and explain to you. I need the z-score for 0.68 multiplied by the standard error of the mean, which is this value, which we will estimate with this value here. So how do we do this? Well, we plug and chug numbers. So this would be equal to our point estimate. If you remember, the point estimate that this was based on was 27. So it'd be 27 plus or minus. What is the z-value for 68%? It is an absolute value of 1. So this would be 1.0 multiplied by what is the standard error of the mean. The standard error of the mean is this value here, which is 3 years. So we could then essentially write an interval that was 24 to 27. That would be our interval around. So the upper limit of what the mean in the population, or so what 68% of the means would be in the population, would be 27. This is our upper limit. This is our lower limit of 24. Well, 68 doesn't capture a lot of the scores, and so we want something that's probably going to catch more of what the variability could be. Well, if you remember, maybe we'll do this one in green. We can collect approximately, if we go out just a little bit wider here, we can collect approximately 95% of the scores and to collect 95% of the scores, what is that equal to in terms of a z-score? Well, it's a z-score of negative 1.96 and positive 1.96. And so then a 95% confidence interval would be our point estimate plus or minus the z-score at 0.95 multiplied by the standard error of the mean. In this case, it'd be 27 27 plus or minus our z-score of at 95, which is 1.96, times the standard error of the mean, which is again right here, 3.0. And so I just had to grab a calculator here. So if we plug in and chug this, you're looking at 1.96 times 3.0 is 5.88. So if we add 27 onto that, we'll be at 32.88. And if we take 27 and subtract from it 5.88, we'll be at 22.12. And so that would be our interval. So now what you could say is I would expect the actual mu parameter to lie, it would be 95% confident that mu, the true mu, would lie inside of this interval. So there's a couple different ways there's at least 6 different ways that you can interpret a confidence interval, but probably the one that I want you to be really familiar with is when you're looking at a 95, this is the most common one. We can do a 99%. If you did a 99%, just by the way, the values here change to if you wanted to go out to 99%, would be a z-score of 2.58. So you could recalculate this, but the interpretation here is just simply that that mu lies within the interval, this interval here, with 95% confidence. Another way of saying that is, if you were to replicate this 100 times, 95 times out of 100, the actual population parameter mu would lie inside of this interval of 22.12 to 32.8. So it can be a little dicey on how you explain these things from time to time, but I think it's completely okay to talk about that this interval is a range of the plausible values for mu. So again, I guess I just want to make sure that the interpretation piece is driven home here. The interval, just for the sake of being thorough here, this is the interval I'm talking about. It's an interval estimate around our point estimate from our sample mean. The interval, this confidence interval, is a range of plausible values for mu. It's based on, again, drawing a interval estimate around this point estimate. So here's the point estimate piece. Here is the interval estimate piece. And what you're saying is we're 95% confident that our interval right here includes mu. Okay? 95% confident that our interval actually includes mu. And so this is just, it's a really good way of kind of showing the precision of your measure. As you can imagine, If your confidence interval was wider, then you would say to yourself, okay, I probably have less precision here. I have less ability to be predictive of what mu actually is. If my confidence interval got very narrow, then you would say, okay, I was probably more precise with my ability to predict what mu was in the population. And so creating confidence intervals around a mean is a really important concept for us. In fact, it's a way that you can do inferential statistics. It's a completely separate way that you can do inferential statistics. It's not something we're going to talk about in this class, but I do think being able to calculate a confidence interval and being able to interpret it is very important, because you'll see this in the different studies and the literature that you read. So hopefully that's provided some insight. Again, there'll be some supplemental materials and videos for you to look at in this section, but thank you for watching the video.